here to talk to you a little bit more about my personal story and how I've gotten to where I am. I grew up the youngest out of three daughters. Lovingly referred to my dad as the third unsuccessful attempt for a boy, which is a very problematic expression, and we're not even going to go into it. But he was a big factor in how I ended up in construction and where my passion for making buildings came. With all the girls, he just needed help, so I was there to help him. He would be one of those people that constantly makes things around the house, whether it's going to be redesigning the garden wall at the back, or making a new garage in the front, or making a little studio for my mom's endeavors. There was constantly something going on. And I was there with him, you know, sifting sand to mix with cement, laying bricks, even tying connections in rebar for slabs. I found that fascinating. I don't know if it was the scale of things, if it was the fact that there was just a dusty substance at one moment, and then we had something standing out. But it really got to me. But when I was growing up, when I was going to school, we didn't have things like this one. I didn't get a chance to hear more about what construction is. And in my head, construction was structural engineers and architects. And I mean, architects are always the love interest in a romantic comedy. So obviously that was the thing to go for. And I did start to look into more detail into what actually architecture was. And the first architect I looked into was Gaudi. Actually, the first ever book I got is up here on Gaudi. And I mean, it's sorry, it's this one, apologies. It is very much a gateway drug, if you ask me. This is Sagrada Familia building in Barcelona, just a fantastic structure with just amazing details in everything that he does. Once I kind of saw these things, I was like, this is it. I'm hooked. This is all I want to do. And this is how I started to pursue architecture. And I went into school. I moved country to come to the UK to study architecture. And architecture school was a lot of fun. It was challenging in many other ways as well, because I had to do 2 part-time jobs to make ends meet. But it was invigorating. And I was really ready to get into it. And I started working as an architectural assistant. That was really interesting. I worked in healthcare architecture quite a lot, which was very, very different from school, because we emphasized design when we were working in school, but once we got into practice, especially with something so specific and technical like healthcare, there's entirely different focus there. And the thing that I liked the best, though, was we got to sit down with the nurses and the people that ran the hospital to actually discuss what was going on. Like, why was it important that a door opens this way and not this way? Why is it important that this room is beyond 2 sets of door and not just one? And it really got me to fall in love with the detail of things, which was very different from my initial impression, you know, with these very fantastic buildings and grand spaces. Immediately, I started appreciating the little things that make up someone's day and could actually, you know, be a difference between life and death, in a sense. That was really brilliant experience. And I kept on working in that. But if you want to qualify as an architect, when I was at the start of my career, I had to go back to school. And unfortunately, looking at the options that I had, I just could not afford to go back to school. Now, this is an important note. And if any of you is interested in pursuing architecture, look into also options for apprenticeships, because things are not like that anymore. You are able to do a little bit of school and then continue your qualification at work. But for me, I had to commit another 2 years of full-time education, which just wasn't possible for me. So I started observing the work and the industry a little bit more and started to think about, what can I find? What am I fitting to develop further in? Because I loved what was happening around me. I loved being part of making buildings happen. And I will go into specifically Ben, but I started discovering it. And I think the biggest emphasis that I want to make today for you is say that in construction, there is so much more than either a very math-driven engineer that scribbles things on a piece of paper, or an architect that makes a big sweeping drawing of an amazing canopy. There is such a huge array of options of roles that you can do that really can weave in between them so many different aspects of yourself. And this is what I found with BIM, because I love problem solving. I love programming. I love putting things in order. I really enjoy the feedback loop with the clients and the people who are really running a building and experiencing it. I do love the people side of things. I love getting solutions to people who are both using the building, but the designers as well. So there's so many aspects. And once I found BIM, it really, my career exploded for me. In the stretch of about a year or so, I started working with some of the most famous architects in the world. I was invited to speak at events to tell people more about BIM. It was really fascinating. My favorite moment of that was me and my partner, we're consultants. We went to have a conversation with Grimshaw Architects, who are a world-renowned architectural practice, who are actually really amazing technologically. And I was a little bit nervous because I wasn't sure, like, we work with small clients. Am I going to be able, like, what do they need from us? They're so great already. And we were sat waiting at their lobby for someone to pick us up. Had in my mind all of the things that I've done. How am I building this case? How are we selling ourselves here? And with all this in mind, kind of ready to go, their BIM lead came to greet us, and I extended my hand and said, "Oh, hi, I'm Katya." And she just said, "Yes, I know who you are. I've seen one of your talks." It was really amazing. So this is kind of what I want to lead to you here, is that there are a lot of things. And once you step into an industry so diverse and big as this one, you can find this perfect fit, and it can really explode from there. And now I just want to spend 3 minutes on a video that could tell you very succinctly what am I actually talking about. Let me just find that for you. Okay, hopefully you'll be able to see my screen now. Is that correct? I will just assume that that's the case. Sorry, not sure. Let me just change that for a second. I'm not sure if you have the sound. There you go. You should be able to have the sound now. Okay.
You can't see your screen yet.
You're not seeing my screen? Okay, let me just check. Thank you very much for your patience. So, do we see a screen now? Now? We should see a screen now. Anyone to confirm?
Yeah.
Great. Okay, let's go then.
What's the technology behind many of the iconic architectural structures being built today? It's a process called building information modeling. BIM is a 3D modeling process that is changing the way people plan, design, construct, and operate buildings and infrastructure around the globe. As early as the 1960s, computer pioneers realized the demand for flexible digital building models. The breakthrough came in 1963 when Ivan Sutherland developed Sketchpad. This rudimentary application allowed users to define geometry and manipulate objects in space with only the help of an electronic stylus on a computer screen. However, these early predecessors built models without data on functional performance characteristics, meaning that without the information on how buildings work, they were rather superficial implementations. In 1984, these BIM forerunners became available for use on personal computers, but it wasn't until 1986, when Robert H. coined the phrase building modeling, that early programs were first used on large and complex projects, such as the renovation of a Heathrow Airport terminal. In 1993, the Lawrence Berkeley National Lab's development of Building Design Advisor paved the way for systems providing performance data on how buildings and their components function. By the late 1990s and early 2000s, the contemporary outline of BIM had started to crystallize. Objects and shapes had fully embedded metadata and were able to understand their relationship with each other and the building as a whole. 2004 was a huge year for BIM. For the first time, designers, builders, engineers, and owners could all work collaboratively on one centralized, dynamically updated model. For example, if a designer made a change to the model, the project's construction shopping list automatically changed too, such as the number and size of windows. 2008, 4 years later, parametric modeling also took a step forward, with an avalanche of design outputs, giving users even greater control over their project decisions. Meanwhile, laser scanning and reality capture filled BIM models with precise, abundant data, saving time in project preparations, and clash detection made it possible to automatically locate on-site clashes, such as ductwork running through beams, and prevent expensive change orders. With help from clash detection, engineers for the China Zoom Tower in Beijing caught thousands of issues in the BIM model. It reduced passive change orders by 80% compared to other similar projects. The indisputable efficiencies in time, material, and cost driven by BIM meant that in 2016, the UK became the leader in legally mandating that all public-funded building projects must use BIM, and other countries are soon following suit. By 2020, Germany is mandating BIM for all transportation projects. With BIM now in the cloud, teams can collaborate on the same model from all over the world, providing great efficiencies. In the near future, BIM and GIS data will merge into one model, helping designers make crucial decisions based on the precise geographic location. As 3D modeling technology advances and is more commercially accessible, the BIM process is becoming more and more integrated with building the wider world, promising a richer, more collaborative experience for users designing and building the spaces we live and work in.
Now, that's pretty cool though, isn't it? This is, in a nutshell, BIM for you. And this video shows an ideal case scenario. And the reality of the world is that not each project looks like this, unfortunately.
All right, welcome everybody.
Oh, sorry.
How's everyone doing? Good classes today? Yes? Yes,
I think that's a relevant question for everyone online.
Sorry about that. So yeah, not every project looks like this. And it's important to understand that it takes a while for things in the construction industry to change, but it is extremely delicious to be at the forefront when things like this are happening. So you still very much have the time to be there because things are changing as we speak. The thing that Mike talked to you just now, it's kind of the finished beautiful cake at the end. The dashboards that he showed, excellent kind of illustration of what is possible to happen and how much information like that can optimize the way we run a building. But before you get there, you need to create that information. And it can happen very much within the process of building. So this is something that he showed you as well in a slightly different diagram, but this is the life of a building. And before you get to the running of the building, there's a whole story that develops, and that information still exists. So what I do is I consult different kinds of design professionals within construction, like architects, how to create that information in a way that it is useful throughout the whole process. And it's interesting to kind of look at as well how people are doing things traditionally, because it is a significant difference. And a big part of it is the technology, and the technology is a lot of fun. But also there's a different kind of collaboration that happens. So, for example, traditionally you would have the architects and designers develop a certain design, and they will freeze what they're doing, and they'll give the information to a structural engineer. They'll do some amendments, they'll suggest some changes, then that will move to a mechanical engineer. And then the process will go back around to the same specialists to make sure that their agenda is still kept. And this takes quite a while. It's a time that we don't usually have. With BIM, what we do is we grab one of those models, and as you saw in the video, everybody starts working there at the same time. Now, with collaborative working like this, however, when people are not used to doing it so much and are much more used to trying to make sure that their work is perfect first and then show it to the rest of the design team, it can be a bit hard. And a very exciting part of my job is actually getting people together and facilitating that collaboration. So apart from being quite technical and being involved in a little bit of visual programming, data management, and so on, I also have a very people-oriented side of my job, and it is a lot of fun. In this process, the way you look at it like this, you get to the later stages as well. So you get quite a lot of efficiency with saving time when everybody's collaborating together. But then when you go into the operating side of things, the way things used to be, imagine there's a lot of documentation that needs to be produced for a building to happen. And there are plan drawings, elevation drawings that describe the building as much as possible in a traditional sense. Sometimes when you're just doing in two-dimensional drawings, there is significant risk of missing something. And you only understand that when you're on site and you already have a full column standing up and a duct order that's halfway installed. And let me tell you, it's much, much cheaper to replace a virtual duct than it is a real life one. And this is kind of the aim, to build the building virtually first, so you can eliminate all that waste and all of those mistakes. And another good example, when you look at, for example, trying to maintain a building, before, when I say before, unfortunately, a lot of buildings still very much work like this. If, say, a door broke, you would have the facility manager open a dark, dusty room full of a lot of documents, bits of paper inside, and try to find a plan of the floor where the door is. Hopefully, with fingers crossed, that facility manager can read the plan. Not everybody can. It's not a given. They'll find the door. They need to find a reference in a tiny, tiny little font next to the door to then go and open a big, big text document that says exactly what door that was. They need to go into all the pages of it. Then they need to figure out what the manufacturer is and then try and contact them and figure out how they're going to reinstall it. Now, with things that you saw in the previous presentation, instead, the facility manager opens up a 3D model of a building, which is something that we all perceive. Everybody can understand a 3D model of something because this is the world that they experience every day. They can tap on the door and they can see all the information that they need for the replacement immediately because it's attached to the door. For example, this is a working, it's not a platform, but it's a working model like this. You can see across to many different drawings. You'll see one component, and then you'll be able to see a lot of the data attached to it. You are able to even, in a dashboard like this, you may have a functionality to immediately trigger a purchase to a new door. So this is generally what I do, and I really love doing it. And saving the world is a big thing. And when I was first asked to talk about this, it was a little bit overwhelming. And I think it's important to know that, you don't have to save the world. We're all going to try, but it's a big task. And trying to do a job very well, trying to do a job in a way that's future-proof, which digitalization it's at the heart of, can really shift the way we experience and use our world. When we have digital data available to us to analyze what we've been doing, we can really improve it. Because we have limited capacity over here, we forget things, and that's a normal and natural thing. We can use digital technology to remember it for us and do it better next time.